This is the second lesson of the next generation security management training based on the R80 release. In this lesson, we're going to cover the installation phase as well as the architecture around the next generation security management solution. First of all, let's talk about the installation phase. In this part of the presentation, we're going to talk about different deployment options. We're going to talk about getting started with R80. We're going to cover the hardware requirements, hardware compatibility, and some limitations that we have in the current version that will be addressed in later versions. So let's start off with the deployment options. Basically, in R80 general availability, it's all about management. There's no gateway solution within R80. In R80.10, the gateway part is going to be available. Basically, it's all about small and large. So you can install the R80 security management solution as a single domain in the same way as we've been able to do it in the past, either as a dedicated security management server, a dedicated log server. You can deploy it in high availability, and it can also act as a dedicated smart event server. You can, of course, run those functions like management, logs, and smart event on the same machine. It's also possible to deploy it as a multi-domain server, either just a single standalone server, or you can deploy it as a multiple domain solution with multiple different MDS servers with different domains in each server. So you can basically scale out in the same way as you've always been able to do with the multi-domain environment. You can install it as a dedicated multi-domain log server. It supports high availability, and you can also deploy it in multi-site in multi-domain environments. So you're running some domains active at some sites and other domains active at other sites in the same multi-domain management solution. Please note that you cannot deploy it in a standalone deployment, so everything in one machine. So you can't have, for example, a management server and a gateway running on the same platform. This will be available when we release R80.10. In terms of security gateway part, this is not part of R80. R80 is a management-only release, and the security gateway part will be available in R80.10. So currently, the supported operating system today is Gaia only. We're going to have support for Linux Red Hat coming in R80.10. What about Windows? Management for Windows is planned for post R80.10, and gateways? No. Getting started. It all starts with an ISO to do the installation. Same procedure as last year. There are some different installation options. This is not specific for R80. This also works in pre-R80 versions. So of course you have the DVD or ISO-based installation. That's great for open servers or virtual machines. You can also deploy it over a USB key, perfect for appliances. And then you can also use PXE or Kickstart if you want to do repetitive deployments and automation in a cloud solution, for example. This is how you're going to see the installation phase when running the ISO on an appliance. So in this case, we're using the USB key installation part. After the installation procedure, you just need to reboot systems. Now there is a small difference in the first-time configuration wizard, so please pay attention to that when you're executing it. So once we're starting it, we will see that you only have the option to select security management because R80 is a security management only release. R80.10, that's when the gateway part is going to be available. You also have a new option now to directly from the first time configuration wizard use the Gaia administrator as the administrator for logging into the graphical user interface, Smart Console, to configure the security policies and other parts of the Checkpoint environment. Once that is done, you can just continue installing or configuring the solution. Same way as before, in the first time configuration wizard, once you select security management, you have a couple of different security management roles. So you can configure security management as a primary, a secondary, or a dedicated log server or smart event server only. So yes, it supports high availability. You can also, of course, deploy it as a multi-domain server from the first-time configuration wizard, same thing as before. If you select that, you need to configure if it should act as a primary multi-domain server, secondary multi-domain server, or a dedicated multi-domain log server. Then you need to select your leading interface where you want to enable your domains and your domain IPs, and then you'll configure the hosts that you're allowed to connect to the multi-domain server from. Please note that hardware validation checks are going to be attempted during first-time configuration wizard, which means that if you're trying to deploy R80 on a multi-domain server with lesser than 4 CPUs, you're going to get this notification. If you're trying to do this, it will disable log indexing. Please add more CPUs and then enable log indexing to get full functionality in a multi-domain environment. Once you have deployed R80 security management and configured it, you will be able to log into the Gaia web interface. And as you see, the icons and graphics have changed a bit to be adopted to the R80 graphics that we have in Smart Console. Hardware requirements, or basically what it takes to get off the ground with R80. The Checkpoint Smart One appliances that are supported for R80 are the Smart One 205, 210, 225, 3050 and 3150. Now please note that Smart 205 with Smart Event and Security Management running R80 on the same hardware is not a good solution. The 205 is not strong enough to provide good user experience. So please do not run 205 with Smart Event and Security Management on the same hardware. It works perfectly fine if you separate it, so if you use a 205 as a dedicated Security Management or a 205 as a dedicated Smart Event server. I wouldn't recommend to use the 210 either, because both the Smart One 205 and the Smart One 210 are dual-core CPUs. You would like to have some more horsepower in R80 when you're running security management and Smart Event on the same machine. And in that case, I would recommend to go up with a 225 instead. For multi-domain servers and multi-domain log server, you need to use 3050 or 3150. On OpenServer, the hardware recommendations for a security management server to get a good user experience is to have at least 4 cores with strong CPUs and at least 8 gigabit of RAM in memory. In R80, the new Java processes are multi-threaded. The R80 server is designed to efficiently utilize available hardware resources to maximize performance and do scalability. So therefore, we recommend that you leverage this advantage and use the most powerful hardware available to get the best performance when working with the management server. If you want to check the multi-threads on a single process, you can first try to grep different Java processes with the ps-ef. Then you can search for a specific PID, for example ps-p, and the PID of the Java process you want to look at, for example, let's say CPM. Then you use the flags LFP to see all the different threads. So here's an example where we're looking at the different Java processes. Then in this case, we're specifically looking at a PID Java process with the number 17539. So 17539 is the Solar process doing indexing of logs and database objects. So as you can see, this is an 8-core machine, and these are the multiple different threads that I'm running on this Java process for this single process on multiple different threads. So yes, if you have more horsepower, more CPU cores, you can get more power out of R80 since it's multi-threaded. OpenServer hardware recommendations for multi-domain servers is to use at least 8 cores of CPUs and 32 gigs of memory. For Smart Console, we would recommend to have at least 4 GB RAM available on the client machine and 2 gigs of available hard disk space. We do support the Windows 7, Windows 8, 2008, 2012 servers, as well as Windows 10. Those 2 builds that are specified here are the 2 official Windows 10 branches that Microsoft is officially supporting and updating. So those are the ones we are supporting to run R80 Smart Console on. For open servers, I'm referring you to the Gaia hardware compatibility list, where you can find the different open server platforms that are supported with R80. So they are certified for R80 today. In terms of hardware compatibility, please do not try to use your old IP appliances, old UTM-1s or Power 1 units, as those have not enough memory to handle R8. So you can probably do a hardware refresh. In terms of limitations, these are the management software blades that are currently not supported but will be supported in the future. So in R80 we don't have smart provisioning. So if you have a customer running smart provisioning and would like to upgrade to R80, that is currently not possible. They have to wait to later releases where provisioning is going to be available in the next generation security management product. Smart workflow, it's an approval workflow cycle doing, for example, 4i principle and allowing rule-based reviews. This is partly available in R80, so R80 is built around a workflow process, but all the features are not available in R80 today. So for example, the approval cycle with 4i principle is not available in R80 today. So if that is something that a customer is using, they can't upgrade at the moment to R80. That will be available in post R80 releases somewhere later. Smart Portal, the legacy web-based management functionality, has been replaced with our security management API, allowing customers to build their own web-based portals to integrate with the R80 management server. And SmartMat has nowadays been discontinued because we saw that customers were not using it. In R77.20 and R77.30, we had add-on packages, adding new features on top of those versions. Those features are currently not part of the R80 release. It's most probably going to be available in R80.10. So if you're using Threat Extraction Blade, using SAML for authentication for cloud-based services, or threat indicators, or managed Modbus protocols, then at the moment this is not available for R80, but will be in R80.10. Before doing upgrades, please read the known limitations. The known limitations contains a full list of what's currently not supported in R80 today that will be addressed in coming releases. In the second part of this lesson, we're going to talk about the architecture around the next generation security management solution based on the R80 version. In this part, we're going to talk about the components, the main processes, the database structure, and then we're going to put everything together inside R80, as well as covering what we can do if things goes wrong and how we need to troubleshoot that. So let's start off talking about the different components and the architecture. So the next generation security management server and architecture is still built around a three-tier architecture within Checkpoint, where the Smart Console is a Windows-based graphical user interface tool for administration of the Checkpoint management servers. The R80 Network Security Management Server runs on appliances, open servers, and virtual servers. It's a secure distributed architecture allowing administration of multiple enforcement points from a single management platform, using modular security architecture allowing addition of security management and logging features. Then we have enforcement points to enforce the security policy in the enterprise network, next generation data centers, public, hybrid, and private clouds, as well as cloud security as a service, remote offices, and remote mobile devices. So this is constructing the three-tier architecture within Checkpoint. Within the R80 Security Management Server, we have three main components. We have the PostgreSQL database that contains objects, policies, users, administrators, license, and management data. So this is basically what's powering the change. This is a relational database allowing concurrency of administrators. If you're searching for the obvious50.c database file within the R80 Security Management Server, you will find it and see that it still exists. This file is no longer used to store database objects, but it's only generated during pulse install for backward compatibility gateways, pre-R80.10 gateways. Then we have a new main component called Solar. It's powered by Lucene, so Solar enables powerful matching capabilities using indexing. So basically, it enables administrators to quickly find objects in the database and quickly locate specific record records. So what Solar is doing is basically that indexing the information inside the database as well as the log files from the log servers in the architecture. You can still deploy a secondary management server providing management high availability in case the primary management is unavailable. And synchronization is achieved over secure internal communications. You can distribute responsibilities, so you can install a dedicated log module to provide offloading of workload to dedicated servers for log handling, as well as installing a dedicated smart event server to provide offloading of workload to a dedicated server for event analysis and reporting. These three components can of course be combined into one single server. As mentioned earlier, the next generation security management based on R80 do support multi-domain security management solutions, and yes, you can deploy that in high availability with multiple MDS servers for redundancy and scalability, so you can scale out your infrastructure. So these are the different management server roles. This is nothing new compared to previous versions. So of course, the management server handles policy configuration, maintain and deploy the policy among the different managed gateways, aka enforcement points. It acts as a certificate authority, generate, manage, and validate certificates for different purposes, such as secure internal communications and VPN. The management server will by default act as a log server, and it also contains status monitoring the managed servers and gateways, for example, CPU, RAM, consumptions, interface statuses, etc. And these can be seen in the graphical user interface in Smart Console. Let's continue with the main processes inside the next generation security management based on R80. So we have our GUI client. The GUI client communicates over a new port, TCP 19009, towards a new process called CPM. Then we of course have the traditional processes like FWM, FWD, CPD, CPCA for Certificate Authority, and CP Watchdog. I'm not going to cover all these old processes. There are more information hidden inside the slide deck for self-study. So what is this CPM thing that we have in R80? So this is the main management process. Basically what it does is that it's serving the GUI clients on TCP 1901 over the CPM web service. It's communicating from the client side to the server side, or SOAP. It's handling database tasks like creating, deleting, and modifying objects. It's doing policy compilations. And it also empowers the migration from our legacy client-side logic to a server-side logic. Because in R80 today, we have a server-side logic instead. If you might remember in the past, when working with, for example, Smart Dashboard, and you did a lot of changes, but you forgot to press save, and then your graphical user interface crashed. What happened was that you lost all your changes because you had a client-side logic where you did all the logical stuff on the client side, and once you press save, those changes were saved inside the Objects5 database. Now, in R80, we have a server-side logic, which means that the intelligence is on the server side. So the client, for example, if I'm opening an object, will send a request to the server, provide me information about this object. It's going to show you the object details on the client side. If I do a change on the IP address of that object and press OK, it's going to send commands to the server side saying, okay, inside this session we changed the IP address of this object, so let's store those changes inside the database for this session. Now if the client crashes, all changes are still stored on the database. You will not lose your changes. You can just reconnect with your client and connecting to your session and continue working with your changes. So this is the server-side logic that we're providing in R80. The CPM process also provides architecture for consolidated management consoles. So in R80 Security Management Console, you will see that all the different aspects in there are consolidated into one graphical user interface instead of having multiple different applications. So these are the different processes that the main process is controlling within the R80 server. CPM controls the startup of the CPM process. It's a new Java process deployed as jar file on the management server. It manages the web server, providing web services to graphical user interface clients and other remote clients communicating over, for example, the Security Management API, responsible to transfer the request to the DLE server. The DLE server contains all the logics of the server to write the info down to the database. Before the information is written down to the database, you have the object store, that is the translational mechanism that writes data into the database. The database consists of a PostgreSQL database containing all the object information, policies, users, admins, license, and management data. In addition to that, we have Solar. It stores most of the data from the database used for full text search capabilities. It enables powerful matching capabilities including phrases, wildcards, grouping, and much more across any type of data. Now, the Solar Web API can be reachable locally over 89.83, but it's not remotely accessible. All access to the Solar database needs to be passed through the web services process inside CPM to be validated to ensure that we're following a secure framework. So if you're trying to reach the Solar Web API remotely, you will get the error connection refused, but you can successfully do this locally on the management server, as seen in this slide. Now, a much easier way of putting it is basically that the CPM is the coordinator, the director, the logician, the brain basically of the operations around the next generation security management server based on R80. Just a recap, what is this FWM thing? So that is also a security management process. On a multi-domain environment, we will have a FWM process per domain and also one process on the MDS part. So what does it do? It provides client authentication services when trying to access CPM. It does policy installations towards backward compatibility gateways and provides backward compatibility functionalities. It supports operations that still require this complex client-side logic that have not yet been merged into the new smart console infrastructure. In the next section, we're going to talk about the database structure inside the Postgres database in R80. In R80, we have a new database format. Everything is divided with something called domain IDs. So the database is structured in different domain IDs. It should not be confused with domains in multi-domain. So in the database, we have different system domains separated with different domain IDs. For example, global domains, CP data domains, IPS domains, API domains, log domains, etc. And then we have user domains separated into different user domain databases. Now the global domain exists in a security management server, also known as Smart Center, but basically it's blank. It doesn't contain any objects. This is used as the global database inside a multi-domain security management environment. The system domain is the database domain that contains admin users, trusted graphical user interface clients, permission profiles, and so on. So when using the API, for example, and you would like to create an admin user, you will notice that you need to log in to the system domain inside the Postgres database to do changes for your admin users, even though you're not using a multi-domain management server environment. The Checkpoint data domain is a read-only domain inside the Postgres database. It contains the default objects populated by Checkpoint when doing an installation of the management server. For example, the different services that they have in there, the default office mode pool, and so on, etc. The IPS data domain contains the IPS signature updates. The nice thing with this dedicated domain is that it allows for independent rollback of IPS updates. In the past, you might remember that people took full database revision controls before they did an IPS update, and then if something went wrong, they need to revert back to database revision. This also reverted back the policy changes of the security access policy, for example, since it was a revision control of the entire database. In R80, we have different revisions of the signature updates. So our administrator can freely choose which signature update you want to revert back to by selecting one of the signatures from the IPS domain. We have the same situation for the API domain, so we save different revisions of application intelligence URL filtering updates inside that domain, inside the database. The log domain contains configuration data of the different log servers that are connected to this management server. The SMC user domain is the domain where the end user is creating his own objects, services, is the rules repositories with the policies, the different layers. On a single security management server, also called a smart center, we only have one user data domain, while in a multi-domain server environment, we will have one user domain per domain we're creating in the multi-domain environment. Since the database structure is identical for security management server, also known as smart center, as for multi-domain servers, this basically means that this database is future-proofed for migration into MDSM environments. So hopefully in the future, it's going to be more swift to migrate from a single domain security management server to a multi-domain security management server. So let's put all these different components together. The Smart Console on the client communicates to the server using TCP port 1909 with the CPM process on the R80 security management server. CPM is a process that is responsible for writing all the information into the Postgres SQL and the Solr database. The CPM process, once the client communicates, will send an authentication request to the FWM process. The FWM process still exists for backward compatibility gateways, V6 operations, and more. For example, the client-side logic. More about this can be covered in the coming lessons. Once the client is validated, the FWM process sends the authentication reply back to the CPM process. The CPM process then communicating to the Postgres SQL database where information is validated in the DLE server before it's being written into the database and checked with the object store. All data is saved into the Postgres database. It also communicates to the Solr process. Solr generates indexes of the data written to the database for quick search capabilities within the objects inside the Postgres database. Just another concept to remember within the security management server based on R80 are sessions. And you will hear a lot about this in the coming lessons. So basically, when working and doing changes using the Smart Console graphical user interface, or for example the R80 management API, an administrator is always working within his or her own private session. When you're doing a change, you're doing a change inside your session. Those changes are not going to be available for the other administrators until you have approved those changes by publishing them to the database and releasing them from your private session. So all changes done is done within a session, and then you publish them, and then they're going to be available for the other administrators. So let's cover some small hints on what we can do when things go wrong. So as mentioned earlier, CPM is responsible for starting and managing the processes associated with it. The DLE server, the web service, the new jar files, for example, the CPM jar file process, the object store, and so on. CPM is monitored through Watchdog, so you can run a command called cpwd_admin list to validate that the CPM process is indeed executed. And you can also check that it's not restarting, because if you see multiple restarts here, that would indicate that you have a problem with this process. If you run ps-ef grep java and look for the D flag, you can see the different Java processes executed from the jar files. To identify issues with CPM, for example, if you cannot connect with Smart Console, you can validate that the jar CPM process is actually up and running with this command. If you have problems with indexing, you can check that Solar is actually running, checking the CPM_Solar in the D flag is up and executed. Now, ELG is the place to be. So if you have issues with CPM, go to fwd/log/cpm.elg and check if you can identify what the issues are by checking the output of this log file. So this is the log that you should send to Technical Assistance Center when you have issues with CPM. For example, it's not running, you can't connect with Smart Console, etc. So cyclic, yes, this log file rotates. It can be configured using the fwd-conf-tdlog cpm configuration file. The CPM server, as mentioned, is listening port TCP 1909 when you connect with Smart Console. Solar is locally listening on 8983, so you can validate that it's actually indeed doing that, and Postgres is listening locally on 5432. So we can also validate that Postgres database is up and running and is local listening on this port. These are some basic troubleshooting steps that you can do to identify where you have an issue, and then you can move forward opening a ticket with Technical Assistance Center, providing them the correct information.